So, welcome to this lecture. Today's topic is tools and techniques used for ergonomics. So, today we will know what are the tools and techniques used for ergonomic assessment, and in context with knowing what kind of methods or tools or techniques available for analysis in the ergonomic area. So, before that we have to understand that what is the role of ergonomic person. So, and as well as how can an ergonomics contribute to the technology development in industrially developing countries. So, this can be achieved by adaptation of new technology which is already present in Western countries, and it can be achieved by improving working conditions through ergonomic interventions. It can also be done by developing traditional methods in acquiring modern technology and also in modifying existing techniques. So, these all factors need training and education in ergonomic, so that they could experience the existing situations, and based on their experience and knowledge they could contribute towards ergonomic. So, as far as ergonomic contributions to development in industrially developing countries, so the research on basic data needs, the promotion of spatial abilities, so and refining of simple methods, more appropriate experts, action learning like learning by doing not imitating, and better supported education and research, as well as reconceptualize standard settings. Why this ergonomic is important? Because as far as if you will observe these facts that is given in this particular slide, so you will come to know that due to inadequate attention given towards human factors, there are a lot of diseases and complaints emerged out in the system. So, this is a present trend of occupational diseases and complaint, where this particular ergonomic factors are having maximum percentage of diseases and complaints. There are various chemical factors in industries. That particular factor is having about 22% of diseases and complaints. Noise factors are having around 12% of disease and complaints. Biological factors are having some approximate 3%, and other causes are having around 9.5%. So, these are the major factors responsible for several disorders or disease, or the factors that are adversely affecting the system's performance. So, these all complaints have emerged out because of several reasons in any organization. So, mostly in any organization these complaints have come out because of more sedentary work, fewer distinct work types, less muscle usage. Appropriate physical effort is also important in order to maintain a human's health, particular person's health, and more static than dynamic work. Like nowadays this computer workstations work is mostly being performed by workers in any organization. So, it also leading towards several diseases and lot of complaints regarding a person's health. Now we will slowly moving towards knowing tools which is nowadays being used in anthropometric analysis. So as we are aware, this particular anthropometry is a very important part of ergonomic. So first of all, just to recall that what is this anthropometry is all about. So anthropometry is derived from Greek word. Anthropos means human and metron means measure. It basically refers to measurement of human individual. So this anthropometry plays a very important role in industrial design, clothing design, ergonomics and architecture, where statistical data about the distribution of body dimension in the population are used to optimize products. So changes in lifestyle, nutrition and ethnic composition of populations lead to changes in the distribution of body dimensions. So this variation, because of this variation, the analysis is now becoming more complex as the days are passing. So it also requires regular updating of anthropometric data collection. Like for a workstation, platform is aimed to design so that it will suit for all workers. Workers are different in many aspects, such as like that variability can be because of age, height, physical sizes of individual persons, etc. So the analysis of human body should be necessary in anthropometry data and in anthropometric aspect, and there are very good sources of anthropometric data are available. Like every country in fact has a separate data based on their age of population, and several researchers have also accumulated that data based on the discrimination of their age and ethnicity as well. So in 1996 one scientist was named as Friesent in 1996, and another scientist named as Roebuck in 1995. So they provide the anthropometric data of civilian. Basically this Roebuck is from US, so he provided anthropometric data of civilian in United States, and another kind of software which you can think to perform this anthropometric analysis. So one software I am recalling here, that name is People Size 2000. So this is a particular software package that allows a user to click on relative measurement and then select age, group and nationality and percentile value. So in this way this particular software will give you proper value of relative measurement of various parts of a body. Anthropometric database was at the outset initiated by one scientist named as Armstrong, who was working in aerospace medical research laboratory. So this was all about the history of anthropometric data capturing. Now as far as this analysis is concerned, anthropometric data for a particular size of population usually obeys normal distribution curve that we have studied when we were covering this particular topic individually, separately. So the published data indicate not only mean values but also some measures of dispersion. So mostly this particular choice of a data is made based on the percentile. So as far as minimum dimension is concerned, we choose 5th percentile of the data, and if maximum dimension, I have stated sufficient example in that particular lecture about in what situation you will choose the 5th percentile, and in what situation you will choose the 95th percentile of a particular data. So that is the discrimination between minimum dimension choice and maximum dimension choice. So here as per the revision of that particular topic, so 5th and 95th percentile points common. So we also take care of the standard deviation, and based on the standard deviation we collect the data based on the mean and standard deviation. So this basically standard deviation applies to specific anthropometric variable like heights of the female from northern Europe. So this is in brief the normal distribution curve in anthropometry, in which this particular graph is following a normal distribution curve, and here this particular portion is capturing the 90% of the population information, and this particular bar is showing the 5th percentile value, and this particular from the right side is having 95th percentile of the value. So for a detailed understanding of this particular curve, I have covered this normal distribution explanation in a particular lecture of anthropometry. So you can revise that particular lecture. So in a nutshell, this particular normal distribution curve can be the data can be chosen from that curve on the basis of minimum dimension and maximum dimension. So a high percentile value of an appropriate anthropometric dimension is chosen. So as an example, while designing a doorway, sufficient headroom for very tall people has to be provided, and 95 to 99 percentile stature could be used to specify the minimum height. Doorway should not be lower than this minimum value. So this particular doorway is a very easy example that anyone can take and perform the understanding of that particular minimum dimension concept. So here as far as designing a doorway, additional allowance also would be taken care for the increase in the height caused by heels of shoes, protective headgear, etc. There's another example of using a minimum dimension is seat breadth. As far as the maximum dimension is concerned, a low percentile is chosen as in determining the maximum height of a door latch, so that the smallest adult in population will be able to reach it. So since we are here applying the choice of percentile value, so we also have to have knowledge of calculating percentile value. So this percentile may be calculated with the help of mean and standard deviation. So the pth percentile value can be determined by m plus z times is sd, where m is the mean and z is the standard deviation. Z is basically z score, which is found out with the help of a normal distribution curve and a standard deviation. So now coming to the existing resources available for anthropometric analysis. So there are various software program which provides additional information about anthropometry. So Anthropos and Ramses, these are the software tools which will give you basically those softwares allows users to load a virtual human into 3D space. So similarly, those softwares have been developed like Delmia SafeWork from delmia.com, Ergonomics, Jack Human Modeling, Life Mod Biomechanics, and this Mannequin Pro from nextgenrego.com. So these are the softwares that have been developed in order to perform this anthropometric analysis, and basically this ergonomic part contains the information based on the survey and questionnaire. So this is the powerful tool of survey of if they want to, let's say, have some particular design confirmation. So what they do, they generally take opinion of more than 200 people, and by just formulating a questionnaire, and on the basis of questionnaire they try to take opinion of large number of people, and then decide the next course of action. So this is the generally that survey and questionnaire tool is the one of the research technique through which any information can be authenticated, certain kind of population is ready for that particular design or something. So in this way, the survey and questionnaire is the one of the tool which is frequently used in ergonomic assessment, and for that some of the percentile calculation is required, and that we do with the help of the percentile calculation, as well as taking out mean and standard deviation and plotting in a normal distribution curve, so that we could specify the certain kind of population is fitting in that particular domain. So in that way, that analysis used to be performed. So now we come to understand what are the existing tools explored so far for ergonomic assessment. So ergonomic, as we have understood the definition, so it is a very broad topic. So the broad topic in the sense that it not only includes the physical analysis, as well as it also includes the environmental analysis and cognitive analysis. So a lot of topics that this particular world is carrying. So here, although I have named, I have tried to collect these all tools and equipments, just to make ourselves aware that these are the tools already existing and that are being frequently used by users. So these are the market tools and equipments that is used for several purposes. So we will just have a look over their functioning and for what purpose they are being used in the current scenario. So now as far as tools and equipment used in physical ergonomic is concerned, so if we talk about physical ergonomics, so here the one thing that comes in mind is that automatic postural assessment. And here in this the posture control assessment is the main focus, because everybody sits, and that is not, and everybody sits, and because of sitting for a prolonged period of time, everybody faces some kind of pain, stress or fatigue. So there is a very much scope in this particular area, like postural analysis. So that is coming in the physical ergonomic portion. So this particular postural posture control mainly focuses on the orientation of body in order to achieve a proper balance. So generally it has been found that this posture control is an phenomena that generally does not require attention, and people used to follow a normal comfortable position in which they initially feel very comfortable position, and they feel very comfort in that particular situation. So the posture of an control requires attention that varies from task on the basis of balance and age. So basically many posture of an individual reflects the daily lifestyle. So efforts are made to recognize the early postural problems, and this particular posture assessment can be done in two ways. The posture assessment can be done in quantitative basis and qualitative basis. So this qualitative assessment is used less expensive, whereas this quantitative assessment requires use of computers. As a reliability of such method is still to be enhanced, so there is no as such standardization used to verify certain postural changes, and studies on the reliability of posture assessment is still not sufficient. So basically this posture assessment in ergonomic area is performed with the help of recording and interpretation of photographic images. So we what we used to do in ergonomic, that we take images and then we perform the analysis on the basis of your posture condition. So in that series this particular digital photogrammetry is used for this particular postural assessment, and it is a simple and highly precise technique for recording and capturing postural transformation. Another kind of tool is acclimage. This acclimage is developed by a physiotherapist. That tool is for quantifying the posture precisely based on image capture. So it also this acclimage also assists to express dysfunction through angle calculation through standardized protocols. So it basically this acclimage transform the image dots to the Cartesian coordinate axis and evaluate them. The another kind of tool is all body scan 3D. So this particular software tool it scans the entire body in very few seconds and creates a model. So in that all body scan 3D sensor is utilized to model the patient body, and in 3D, and transferring the data to the software in computers. Another kind of tool is this APLOB, APLOB. This particular APLOB is utilized for again this postural assessment, and one computer is required to utilize this APLOB. So another kind of tool is APID. This particular software provides information about the posture of individuals. So it has assessment stages, the assessment of posture on sagittal plane and assessment of posture on the frontal plane. So in biomechanics we will cover there are certain planes through which this particular body is defined, and based on the view through which we are observing the body, we define that plane. So the front view, side view, or the lateral views. So all the views we defined on the basis of planes. Those planes are the sagittal plane and frontal plane. So this particular tool, this software tool, APID, APPID, is used to assess the posture on various planes. In the similar way, another software is Biotonics. So this Biotonics is used in static posture assessment and balance. So here the type of accessories involved in this Biotonics are video camera, positioning platform, personal computer and computer program. So in that this balancing of a particular human body as well as analysis of posture assessment is performed with the help of this particular Biotonics. Another tool is Corporis Pro. So its major plan is basically the performance of posture assessment of patient and related motion analysis. So it makes it possible to capture images from different sources to process them by means of large set of tools. So in this way this Corporis Pro is doing the posture assessment of medical patient. And the another is Physiometrics. So this Physiometrics is generally with the help of this particular software, performance of orthopedic postural evaluation can be carried out. So it helps in document preparation on postural abnormalities. This particular physiometer posturogram, what it does, it provides computerized assistance to physiotherapist and related specialized of any area. So it basically this posturogram, as the name suggests, that it uses several photos in the straight positions with the help of digital camera of very high megapixel. So with the help of those 6 or several photos, that any function or any posture related analysis is carried out. Another tool is Physical Physio. It consists of posture evaluation software with several phases like evaluation of flexibility and posture and measurement of perimeters, whole body composition analysis. So in that this Physical Physio is performs its function, and Physio Easy is also there, posture print is there, and the SAPO is there. So these are having they are slightly distinct methodology in order to perform this postural assessment. So this SAPO is basically based on the scanning and enables sundry functions like image calibration, use of zoom, free marking of points, measurement of distances and body angles, with assessment either standardized or specifically directed by any professional ergonomist. So in this way this particular this posture print, what it does, it automatically identifies and prescribes the exact posture for a particular entity, and this Physio Easy is used for linear and angular measurement. So it also perform a linear and angular measurement, this Physical Physio. In addition to lots of other secondary tool, so each object measured in the images can be simply moved or edited, and the software can consist of any healthcare proficient to put together clinical decisions because of its easy use. So in this way these are the several software tools which are used in the domain of physical ergonomics, and emphasizely on the postural assessment. So now we will understand about the existing measuring tools used in ergonomic assessment. So basically there are various tools and equipment have been developed. They are having very distinct use. Like some of the equipment that I have listed down here, like digital force gauge, biometrics goniometers and biometrics data log, electromyography, 7-piece hand evaluation set, a Wartenberg wheel, digital force gauge, anthropometers like large anthropometer, chest depth measuring instrument, sound level meter, light meter, heart rate watches, etc. So generally it is not limited to these categories. There are thousands of tools have been developed in order to access in order to analyze particular case, whether case of any ergonomic area, whether it be physical, cognitive, organizational, or psychological, or anatomical. So these are the areas. So just to make you aware of existing tools and how they are giving support in the ergonomic research. So environmental assessment equipment are basically have been developed. So this measuring tool can also be categorized in one category, like the equipment used for environmental assessment. So this may be to equipment which is used to check the ambient, the heat, infrared photography. So this may be better we can take as assessment equipment. So infrared photography for light assessment, for sound assessment, and electromagnetic tools. So these are the possible areas through which this environmental assessment can take place, and there are several equipment have been designed in order to check the performance and productivity assessment. So here is the digital force gauge. This particular, as the name is suggesting, that it's a force gauge with digital display, so that are capable of either force or both force and torque measurement. Some varieties can even be coupled with other test apparatus that applies force. So here its application like the application of digital force gauge in ergonomics can be muscle strength measurement. It can be used for muscle strength measurement, functional capability evaluation, etc. So functional capacity evaluation is the evaluation of a person's health to see whether he or she is capable to meet a particular physical demand or not. So just to check the strength, whether he or she will be capable of performing a particular physical task. So in that, a digital force gauge may have an important place in assessing the physical aspect. So another tool is biometric goniometer and biometrics data log. So basically goniometers are instruments that are used to check the precise measurement of angles. It is used for precise measurement of angles. So this biometrics goniometer are sensors based instruments developed by this Biometric Limited for the dynamics movement analysis of human body part. That is, if you want to check the range of motion of limbs. So data log is a portable device that is to be connected to these goniometers to wirelessly. So let's say the Bluetooth or any module wireless module that can be used. So here Bluetooth is doing what is sending the data to computer or stored the data in for further evaluation purpose. So this biometrics analysis software can be used for electromyography analysis also. So using the data so called with the goniometer. So another thing is this electromyography. So this particular tool, that is electromyography, comes under nerve condition studies. So it is a technique used to evaluate and record the electrical activity by skeletal muscles. This EMG, electromyography, is also written as EMG. So this EMG are of two types. First is surface EMG and second is intramuscular EMG. So this surface EMG is a process of evaluating the muscle activity with two electrodes placed above the skin. This intramuscular EMG requires a needle electrode to be pierced into the muscle. So this electromyography finds its application ergonomic, that it can be used to analyze muscle strain occurred during the work, and also this can be used for work design purposes. So this electromyography is a very important tool in physical ergonomic. Another tool is a 7-piece hand evaluation set. So it is nothing but the several set of equipments for hand strength evaluation. This 7-piece hand evaluation set is used for hand strength evaluation. In that, so basically those hand strength evaluation may be hand dynamometer, it can assess the grip strength. There is another tool, that is pinch gauge. It is to assess the pinch strength. Stainless steel goniometer, Wartenberg pinwheel, functional finger motion gauge, finger motion gauge, finger circumference gauge. So these are the this is a kit consisting of 7 equipments for hand strength evaluation. This Wartenberg wheel, this Wartenberg wheel is a wheel with pin-like teeth for testing nerve reaction. It is used for testing nerve reactions. So this was all about the possible measuring tools, and obviously this anthropometer are nothing but these are the tools for study of human body and its movement and other measuring dimensions. So basically if you go to the tailor who is measuring your dimension for designing your cloth, so he is having a lot of tools. So those tools those tools come in the category of this anthropometers. So any measurement if he is taking with some tools, that those tools can come in this anthropometers. As far as sound level meters and light meters are concerned, so these instruments measure the sound level and in any manufacturing facility this can be used to monitor whether sound levels are within limits or not. This light meter is used to measure the intensity of the light. Similar instruments for the measurement of air conditions are also called a psychrometer kit. So this psychrometer kit is also used in industries and other region where air conditioning monitoring has to take place. So in this way these sound levels and light meters have been developed for those reasons. There is another kind of ergonomic tool is a heart rate watches. So this is nothing but wearable wrist watch kind of instrument that display your heart rate. So this can be used in work design to assess the heart rate variation in workers during the execution of strenuous works. So these were the summary of several tools existing in this particular ergonomic market. So now the next heading we are going to learn about is there are existing CAD software tools for ergonomic assessment. So this may be 3D model toolbox for SolidWorks. So in that data sets for anthropometric data, and we can also custom the model. So basically these CAD softwares, in order to understand the human body, 3D images are essential to analyze. It is essential to analyze your actual body condition. So there are various 3D models softwares have been developed, and those 3D human body models can do simple ergonomic fitting tasks that might be difficult using traditional approaches. So the various computer designing softwares have been developed, and the human body model come in many forms, like 2D drafting board templates, mannequins, 3D physical dummies, which you can find in markets, malls, where the clothes have been you go for purchasing clothes. So various dummies that gives you the proper view of fitting that particular cloth. So that 3D physical dummies are available. So these are the physical tools that has been developed that have been developed. So in that series there are other software tools also. Those software tools are Body Labs 3D model toolbox for SolidWorks. So this basically these toolboxes is just to put the anthropometric validation tools, and this Body Lab is also is a particular software. Basically it's a CAD software for anthropometric analysis. So what it does, this Body Lab collects, digitizes and organization all of the data and information related to human body. The information may be of its shape, various poses and motion. So they set their goal to transform the human body into a digital platform upon and around which goods and services can be designed, produced, bought and sold. So this particular Body Lab software is extract the 3D human body by using artificial. What it does, it extract extraction of 3D human body, and it is done by just by using artificial intelligent tools to extract a 3D human body from different sources. So those may be methods may be MOSH, that is motion and shape capture from sparse markers. So here sparse markers are used in human body to capture shape and postures of different part of the body with respect to time. So this motion and shape capture from sparse markers detect the marker position and create a 3D human body. So this particular mesh is able to capture the non-rigid motion of soft tissues. So in this particular, due to it is more accurate for finding exact shape and position of the body, it is used many places like preparing animation movie and all. For this this mesh is very much beneficial. Like there is another way to develop the various body structures or body's features in a 3D. There is another method is monocular RGB sequences. In this particular sequences strategy, so this 3D geometries and human body model is generally can be estimated from this particular monocular RGB sequence. So these sequence can be found by using any inexpensive RGB sensors by allowing a human to move freely in front of that sensor. So range data in each frame is aligned with multi-resolution 3D body model, and the technique then uses geometry and picture texture over time to acquire precise size and shape and appearance data in spite of unconstrained movements. So in this way these are the methods which Body Lab company which provide these software tools used to perform his human body modeling. Another model of a dynamic human shape in motion is Diana. So it gives the accurate design of human body with real human sensitivity. This particular Diana uses several 3D scanners for performing its 3D human modeling. There is another SMPL, the full form is Skinned Multi-Person Linear Model. So what it does, it speaks to a wide variety of body shapes in common human postures. So different parameter of model can derive from shape, weight and posture of the body. So similarly, apart from this MOSH, monocular Diana and SMPL, there are many other methods which derive from Body Labs. These can be listed here, like FAUST. This is a data set and evaluation for 3D mesh registration, and FlowCap. This is a 2D human pose for optical flow, and many other methods are there, like informed sampler, OpenDR. So these are the methods which can be used for this human modeling and other related analysis. So this particular topic, under this topics CAD software tool, and the software which is freely available as a Make Human. So this particular Make Human is a software tool for CAD which allows a user to design, visualize, analyze the human anthropometry and related things. So it uses 3D morphing technology. So this particular the basic parameter for morphings are age, gender, height, weight, shape of face, details of hands, feet and feature of the face. Another software package is the Michigan 3D SSP software package. So this basically does what? This is the software can be used to calculate the muscular efforts and endurance of muscles for a task or work element. Taking the force, posture and anthropometry dimensions as input, it calculates percentile of workers who have appropriate strength to perform the given task. Performance index is compared by the guidelines given by NISOH. The software also contains a 3D animation to showcase the posture generation while doing the task to visualize the effect prior to job. So these are the softwares just to have awareness of current existing tool for designing as well as analysis of various aspect of ergonomics. So what are the possible application of CAD software tools? So it is used for designing a product or service. So it is used to design a product and service which is more suitable to the human who is expected to use it. These particular CAD software tools is also used for research. So the research requires data, and the data collected and analyzed using these tools helps in widening the scope of the development and research methodologies. Every human being is is immortal, so he used to get some disease when the misuse of the body happens. So the medical domain is a very necessary for curing that particular disease which has been which particular person suffers. So for medical purpose, these CAD software tools are also being utilized. So ease in visualization help in medical fields to perform appropriate cure and preventions. So cure and preventions are needed for human body, and for that purpose this CAD software tools are also giving some sort of support to medical domain. Another area apart from research and medical, the sports and fitness. This is also possible application of those CAD software tools. So those sports and fitness is very much dependent on the study of the human body and its dimensions. So it is also related to the effects of injuries while playing. The techniques which are ergonomically suggested can help improve the performance of a sportsman. Movies and games, tools can be and are used in animation and VFX to add new natural and more dramatic effects which are not possible to generate without digitalization. The effects produced by computer also reduce the risk of stuntmen and the cost of filmmaking in few cases. The gaming nowadays is bringing the revolution. The control are shifted from the fingertips to the entire body. A child used to play a video game in old days with clicking on the buttons by his fingers, but now the control is on entire body, and good example is PlayStation and Xbox, which use stereo camera or similar technology to read the instructions and commands for the game. So this particular area of game and movies that CAD software tools are finding utility. Another area where these CAD software tools are finding utility is fashion and clothing. So the fashion is most important thing is today's world. Everybody wants to look good, and the textile industries are making billions. The accurate and more precise anthropometric data enables the industry or fashion designers to make a good fit, which looks amazing and gets attention of viewers. So nowadays people are running in this category. So these CAD software tools are giving a lot of help in designing clothes and as well as to make a good fit in order to have a proper attention of viewers. So that's all for this particular topic, which was about tools and techniques used for ergonomic assessment and other possible ergonomic area. So before that, just have a fact that do you know that your body measurements equal each other. This was given by Leonardo da Vinci. So, you are probably familiar with Leonardo da Vinci's famous sketch Vitruvian Man. So, it is one of the earliest and best exploration of anthropometry or scientific study of the measurements and proportion of the human body. As we mentioned, your foot will fit neatly into your forearm from elbow to wrist, but did you know that your height basically equals to the span of your arms when you stretch them out to the side? Your height is also roughly 10 times the length from your wrist to the tip of your middle finger and about 7 times the length of your foot. This kind of anthropometric correlation is not just fun to know. An anthropologist might use it to determine how tall the owner of a particular bone was, and a forensic scientist might use a footprint or a handprint to estimate the height of a criminal. If you were a civil engineer, how high would you allow the roof to be fit all type of people? This is an anthropometric question. So, graffiti for you, enjoy it by seeing it. These are the references, possible references that I have from where I have collected these data of CAD software tools and other tools and techniques used for ergonomic assessment. That's all for now. Thank you.